This video introduces the main content of our manuscript. It's not a secret that low-altitude air city transport has attracted more and more research because the number of drones continues to explode. Several centralized and decentralized control algorithms are proposed for low-altitude air traffic systems. Among them, free flight is a developing air traffic control method that uses decentralized control. Based on this, different airspace structures were investigated in recent research, such as layers, zones, and tubes-based airspace concepts. Under structured airspace concept, the temporary target of each UAV is always a chain of lines rather than a chain of points corresponding to the boundary of regions, which is in contrast to the unstructured airspace concept. This is formulated as a free flight control problem. First, a multicopter control model is introduced, which includes the kinematic model, the filtered position model, and 3 types of areas. For each multicopter, the control objectives includes the convergence to its destination line and collision avoidance with others. These are both reflected in the proposed controller. Further, formal proofs are given in the manuscript. In the numerical simulation, we consider a square region with 250 meters each side. The inflow of this region is dynamic in 5 minutes. Each multicopter will enter the region from a random side of the square with the destination line opposite to it entered. The color of each multicopter is consistent with its destination line. The video shows this 5 minutes simulation. The total number of multicopters is 420. Without loss of generality, for the first 40 multicopters, the figures in the bottom right corner plot the minimum inter-agent distance and the distance to their destination lines. When a multicopter enters the region, it will randomly appear on the line it entered, which may cause a confliction suddenly. This is why sometimes the minimum distance is less than the safety distance, and the proposed controller still works under this case. The result is consistent with the properties of the controller we proposed. Further, the experiment is proposed with 8 tele multicopters in a square region with 2.5 meters each side. As shown in the video, these multicopters finally complete their task and avoid collision with each other in this narrow square. The multicopter that arrives its destination line will land. The experiment shows the feasibility of our proposed distributed controller. That's all. Thank you for your watching.